Good evening, students. Krishna sir again discussing a new problem in kinematics, which is very interesting. And you might have seen this type of questions, but I am giving a generalized approach for that. So this is my credential, and the topic is interesting problem in kinematics. It's a curved motion, curved path motion. We are going for a generalized approach. Okay. Let's see what is the question. A cheetah is chasing a deer running with a constant velocity. The deer is running with a constant velocity along a straight line. This is the line of path of the deer, straight line path. Is moving with a, the V is the deer, is moving with a constant velocity u. Okay. The cheetah speed is constant at V. The speed of cheetah is constant at V, starts from here. Okay, initial position of cheetah is A and deer is B. Their velocity U bar and V bar respectively for deer and cheetah, they are mutually perpendicular initially at starting time. That's what I wrote. The initial separation is L and the V bar and U bar are mutually perpendicular. Their velocity vectors were mutually perpendicular at the initial starting point. Find what? Question number 1. Acceleration of the cheetah. Acceleration of cheetah at the start of the motion. Question number 2. Radius of curvature of the path of the cheetah at the starting point. So radius of curvature is the path. Red dotted line is the path of the cheetah. But the radius of curvature at the starting point. These are the two questions. Understood this? I am going to solve it in a generalized manner. Just see initial position A, initial position B for the cheetah and deer respectively. Deer moving with constant velocity U bar along the straight line path, and cheetah is always aiming towards the deer and moving with a constant speed. Obviously, the path will be a curved line. At any time, if I draw the tangent to the path, that will finally intersect the position of cheetah, position of deer. And the velocity also along the, always velocity tangential to the path, so velocity direction. And this R bar direction, R bar is the position vector of deer with respect to cheetah. This R bar and the velocity of V of cheetah, they are in same line as you see. Both are tangential to the path. And that unit vector along this tangential line is tau cap. And the unit vector perpendicular to the path is n cap. So tau cap, n cap are mutually perpendicular. Right? This is the xy plane. I am fixing our coordinate system. X, Y, Z. Z is pointing above, pointing out of the plane. X here, Y here. X horizontal, Y vertical, and Z is pointing perpendicularly away from the plane. And that origin I am fixing on the cheetah. Cheetah is having a rotation, but this coordinate reference frame is only translating with cheetah. It is not rotating. Remember this. It goes with cheetah, but translating only. It is not rotating. I wrote it here. Fix the XYZ reference frame on the cheetah. It translates without rotation. That XY. Cheetah might be changing direction, but XYZ remains parallel to itself. Okay? Right. This origin O matches with the cheetah always. But cheetah's bodies might be changing orientation, but the XYZ reference frame will not be changing orientation. Z is coming out of the plane. This tau cap is what? Unit vector along the tangent to the path. N cap is the unit vector perpendicular to the path or normal to the path, and tau cap, n cap are mutually perpendicular. Understood this? right? So at any particular instant we'll discuss. A is the initial position I told you, B is the initial position of deer, A is the initial position of the cheetah, and all this whatever I told you I have already explained. Note that the velocity v bar and the position vector of deer from the cheetah r bar are always along the same direction. Already I have mentioned this, v bar, r bar, and this is tau bar. Tau is the tangential vector, unit vector. So r bar, tau cap, v bar, they are all same direction, always. Okay. Therefore, the angular velocity of r bar and v bar are same, because when r bar and v bar are always in the same line, so whatever angle is turned by the r bar, same angle will be turned by v bar. So their angular velocity of r bar, v bar is same. That's a very obvious point. Let it be omega in the xyz reference frame. ये जो xyz reference frame जो कि rotation नहीं कर रहा, उस reference frame में these v bars, r bars, their angular velocity, let it be omega bar. Okay. ये मैं एक वीडियो लेक्चर आपको दिया था 9th जनवरी में, 9 January 26 में, टाइम डेरिवेटिव ऑफ ए वेक्टर. As per that, I'm going to refer to that. What the relative velocity of deer with respect to this cheetah? U bar minus V bar. Obviously, all of you know velocity difference. U bar minus V bar is the velocity of deer with respect to cheetah, or the velocity of the tip of the position vector r bar. That is the velocity vector of deer with respect to cheetah. That means in the reference frame of xyz, the velocity of deer with respect to cheetah is u bar minus v bar. Very simple. Okay. And angular velocity of r bar with respect to cheetah's position xyz, how much it will be? This, how much? R bar is the relative position vector of deer with respect to cheetah cross relative velocity divided by r square. This is, you can refer to this video lecture on time derivative vector. So r bar cross u bar minus v bar by r square. Open the bracket, r bar cross u bar by r square minus r bar cross v bar by r square. But r and v are parallel, so cross product 0. So only r bar cross u bar by r square. This is the angular velocity of r bar with respect to cheetah's position, means in the xyz reference frame, angular velocity of r bar. Okay. R bar cross u bar will be angle between 90 minus theta. This is theta. Then this is theta. This is 90 minus theta. Okay. Theta is the angle between the r bar with the y-axis. Okay. That's what. What should I write? This r bar cross u bar will be r u sine 90 minus theta by r square. In which direction? R bar cross u bar. This is r bar. This is u bar. Cross will be into the plane. So that will be minus k cap. That's exactly what I wrote here. R u sine 90 minus theta minus k cap by r square. So u cos theta by r in minus k cap direction. This is your omega bar. So omega bar of whose omega bar? Omega bar is of r bar vector, position vector. Then what is the omega bar of v bar vector? I told you this omega both of v and r are same only. So because they are always parallel to each other. So omega bar of v bar will be also same, u cos theta by r minus k cap. This you remember. Equation 2. Okay. That's clear. And this is the omega of r bar with respect to cheetah's position is r cross u by r square. That is the equation. But now it's the important point. This is the angular velocity in the reference frame xyz, which is fixed on the cheetah and translating only without rotation. So any reference frame fixed to the ground also will not be rotating. So whatever the rotation of the R bar or V bar with respect to XYZ reference frame, that is also angular velocity of R bar and V bar with respect to ground, because XYZ has no rotation. So whatever the omega you find with respect to XYZ reference frame, with respect to this reference, which is only translating, that's angular velocity of V bar R bar will be same omega with respect to any ground frame also, because ground frame is not rotating or nor it is translating. Okay. So since both of these reference frame will have no rotation, so omega with respect to XYZ reference frame, which is fixed to the cheetah and not rotating, only translating, and omega with respect to ground frame, both will be identical. That's what I wrote here. Angular velocity of V bar with respect to ground frame and angular velocity of V bar with respect to XYZ reference frame are equal. That means the angular velocity of V bar vector with respect to ground is omega bar. This is important. Okay. After this, now we come to the ground reference frame. क्या होगा? V bar is the velocity of cheetah in ground frame. It has a constant magnitude, but its direction changes. A tangential must be 0. That is since the V's magnitude is not changing, so acceleration tangential direction must be 0. Because tangential acceleration means rate of change of magnitude of velocity or rate of change of speed, which is not there, which is 0. So a tangential, a tau is 0. Okay. So only normal component an will be there. Along n cap direction, acceleration will be there because it's a curved path. But tangent to the path, there will be no acceleration, because tangent to the path, the velocity magnitude doesn't change. So because a tangential changes the magnitude of velocity, is not changing. So a tangential 0, only an will be there. This is the an. An means acceleration in n cap direction will be there, which is normal to the path. That is the so-called centripetal acceleration. Okay. So a will be dv bar by dt is a constant magnitude vector V bar. So what is the rate of change of a constant magnitude vector? Same time derivative of the vector. You refer to my video lecture given on 9th January 26. Go to my channel and see this. So what is that? Acceleration V bar by dt is a constant magnitude velocity, but direction changing. So that will be omega of V cross V. Omega V already found out. U cos theta by R minus k cap, and V is V tau cap. So minus k cap cross tau cap. क्या होगा रे भाई? Minus k cap into the plane. Tau cap is here. So if you cross product of minus k cap, that is into the plane, and tangential, it will be pointing in n cap direction. Because k cap cross tau cap will be minus n cap direction. So minus k cap into tau cap will be in n cap direction. That's what I wrote here. V cos theta by R minus k cap cross V cos theta by R minus k is omega bar. Already proven here. U cos, that is the omega will be U cos theta by R minus k cap, equation 2. So that's I'm directly writing U cos theta by R minus k cap cross V tau cap. Minus k cap tau cap will be n cap. So this is U V cos theta by R n cap. Diagram देखो, diagram वही मैं बताया again, मैं आपको दिखा देता हूँ एक बार. This cross product is this minus k cap into the plane, and V cap tangential there, that is tau cap. So minus k cap tau cap will be n cap. Okay, and magnitude is UV cos theta by R n cap. Now there is one more video of the same date, my video lecture, radius of curvature. What is the value radius of curvature? Refer to that. Say VQ of that path for any curve VQ. divided in magnitude of A cross B. That is V cube. Magnitude of A cross B क्या है? How much will be A cross B magnitude? A cross B magnitude. A is this UV cos theta by R n cap, and V is tau cap. Both are perpendicular to each other. Yes or no? So magnitude will be simply AV magnitude. AV is UV cos theta by R magnitude wise into V. So this V square V cancel. So V R goes out, VR by U cos theta. This is rho. Be very careful. V Q by A cross B. A is n cap direction, V is tau cap direction. So cross product will be K cap. So magnitude, if I sign, so I remove the K cap, so only AV. A is UV cos theta by R magnitude wise, already we have proven. So, and V is V. So V square U cos theta by R. R goes up and V square cancel from VQ, that is VR by U cos theta. So this is the rho. This is for any general position of the cheetah. सर इनिशियली क्या है? इनिशियल कंडीशन में थीटा क्या है भाई? अब देखो ये जो थीटा है, as in coming here, y and this velocity v bar, they are matching, so theta will be 0. And initial condition, this r bar is L, magnitude is L, r magnitude is L. So that's what I wrote. So initially theta is 0, r is L. तो वैल्यू पुट कर दो भाई पहले a के लिए. तो a का मैग्नीट्यूड क्या होगा? u v cos 0 by L. u v cos 0 by L n cap. So u v by L n cap. So रेडियस ऑफ कर्व इनिशियली क्या होगा? इसमें r is L cos 0. So bl by u. bl by u cos 0, bl by. ये समझ में आ गया? ये यदि क्लैरिटी के साथ करना. ये रेफरेंस में जो बताया, लोग नॉर्मली क्या करते हैं, इसको मिक्सअप करके बोलते हैं, बट मैंने ऐसा नहीं किया. वेरी क्लियरली मैंने आपको समझाया कि कौन सा रेफरेंस पे मैं यूज कर रहा हूँ कब. ओके, एक थे ग्राउंड फ्रेम, उसको मैं लास्ट में यूज कर रहा हूँ, लेकिन all the omega I first calculated with a purely translating XYZ reference point fixed to the cheetah. But it's purely translating, not rotating with cheetah's body. Moving on cheetah's fixed, moving with cheetah, but not rotating with cheetah's body. Understood this? There's no pure translation. बहुत क्लैरिटी के साथ बोल रहा हूँ. आप बार बार सुनते रहिए वीडियो लेक्चर, आपको पूरी बात समझ में आ जाएगी. ये टॉ क्या पेन क्या मैंने लिखा, जो समझाया इधर लिख दिया मैं, तो आपको कोई दिक्कत नहीं होगी ये अंडरस्टैंडिंग में. ठीक है. लास्टली मैं ग्राउंड रेफरेंस फ्रेम में शिफ्ट करके ए टॉ 0 बी एज कांस्टेंट मैग्नीट्यूड, ओमेगा ऑलरेडी ग्राउंड फ्रेम में ओमेगा एंड XYZ omega are same because both of them have no rotation. So both the reference have no rotation. So angular velocity, any one of them will be same as angular velocity in the other one. So omega bar, now I have to do everything from the ground frame because I am asking questions for the acceleration of theta in ground frame. So omega cross v, dv bar by dt, if the v is a constant magnitude vector, then must be omega v cross v. So that is u cos theta by r, already I have proven, and into and k minus k cap into v tau cap. हो गया ये? आपको समझ में आ गई है? चलो, तो रेडियस ऑफ कर्वेचर को डायरेक्ट मैंने क्या वी क्यू बाई मैग्नीट्यूड ऑफ ए क्रॉस में आके आपका वी आर बाई यू कॉस थीटा, व्हेन इनिशियली आर इज एल कॉस थीटा इज कॉस 0 1, सो वी एल बाई यू खत्म. वी एल बाई इनिशियल पोजीशन रेडियस ऑफ कर्वेचर ऑफ द पाथ. ओके, कोई डिफिकल्टी नहीं है? चलो, all the best to you on your impending examinations. I hope you are doing well in board as well as in your entrance. So these are the conceptual discussions which will help you, help all of you when the teachers also can gain lot from this discussion. Okay, so try to see this lecture, try to understand, try to take it deeply in your mind, but for that you have to refer also to previous lectures which I have given you. On this January 9th of this year, we have discussed this time derivative of vector and also radius of curvature. Same day, same day. Okay, 9th January 26. सो रेडियस ऑफ कर्वेचर से यूज करके आप तो कर लेंगे आराम से. इसलिए मैं बोलता हूँ जो भी मैं लेक्चर दिया हूँ, हमने जो लेक्चर दिया है पहले से, वो आपको बहुत फायदेमंद आपके लिए होगा. आप उसको रेफर करते रहिए, आपको कंसेप्ट तो डेफिनेटली बिल्डअप हो, ये मेरी गारंटी है. एनीवे दिस माय क्रेडेंशियल. आप चिंता की कोई बात नहीं, अगर कोई डिफिकल्टी है तो मेरे से आप पूछ भी सकते हो. Okay, all the best. Thank you. Have a nice time.